Welcome to this video in the Python in Education series for teachers and students and anybody else who's interested. In this video, I'm going to talk about how to make basic 2D plots and walk you through how to do that in some detail. I've discussed this in some of the other videos, but here we're going to get into some of the details and make some plots. Okay, so what and why do we want to do this video? I'm imagining you're a student or a teacher, you teach labs, you're doing a science project, you're taking a math class, and you want to make beautiful 2D plots very easily. You want to save them, send them, print them, put them in a report, give them to your teacher very easily. That's what I'm going to tell you how to do. So let's get started. Perhaps you would like to have plots like these. Here's an example for trigonometry where I compare the sine and cosine function. Very simple. Possibly you have data that you'd like to look at and you'd like to make a plot of your data and put nice labels like this. I'll show you how to do that as well. And here's another example from calculus where I look at the area under a curve. So here's three examples from trigonometry, data analysis, and calculus. And I'll show you how to make all three of these plots. And what's nice, of course, about doing all of this in Python is it's very easy. And when you're done, you simply click on a button and you can save it in a file and put it wherever you want. So let's do that. Okay, so just a little bit of a background. The reason that this all works is because Python is an amazing language, and what it does is it brings in something called Matplotlib, and that provides all the capability for making these graphs. So you just have to get used to every time you want to make one of these graphs, you're going to want to pull Matplotlib into Python, and then you tell Python how to make the graph using the libraries that you pull in, and it will then, at the click of a button, export your graph. So just keep that in mind, that that's sort of the logic of how this all works. Okay, what's great about this is they work on all types of machines from Windows to Unix, Linux, and Mac operating systems. And if you haven't watched some of the previous videos, I talk about how to get all of that set up so that you can use all of this capability. But in this video, I won't be covering how you do that. But at the end of the video, I will provide a link to the video that does tell you how to set this whole thing up. But let's assume you have this all set up and you're ready to get going. Okay, so just a tip before we get started. What you should do when you start making these types of graphs is make a folder and save your scripts. So in Python, when you have a bunch of commands, you can type it in at the interpreter and get instant results from on your screen. Or you can go in and make a file, either using idle, which comes with Python, or some other editor, however you want to do it. And what's nice about it is you can save your file. And as you'll see by the end of this video, saving your file is really useful because you'll want to use that file again, and then you don't have to type everything in. So this example right here might look pretty complicated to you, and there's a lot of stuff to type in and all these little details. Well, what's nice is if you save it and you bring it back up next time, it's a reminder of everything you did and you don't have to start from scratch. So take your script, take your example plot, save them in a folder, and you can have them available next time. So don't start from scratch, start from example. And in fact, you can find many examples like this on the web. Okay, so let's get started. Let's start by thinking about what makes a great graph, and I'll walk you through that, and then I will show you how to do each of these things. So let's take this graph as an example. What does it mean to you? Probably nothing. So one thing we probably want to start with is putting a title on that graph. But even if I put that title, it still doesn't tell you quite what I'm showing. So step 2, make sure you always label both of your axes and put the units on there. So here I have year and I have, for example, % of GDP. That's an important thing to do. Use color and different line styles. So here's an example where I have circles and dashed lines that are between them, and I can even make those slightly thicker Hope you saw that. And that makes it a lot easier to read. Still, I don't really know what the blue line is, and I don't really know what the red line is. So another thing you should always think about including is a legend. And now you can really understand what this graph is. Two questions you might want to ask yourself is, should you have grid lines? Here's what grid lines look like. Some people would say don't use grid lines, they just make it very cluttered. I actually like grid lines because I want to know precisely what those values are. But you have to decide in the context of what it is you're doing whether you want to have those. One of the nice things that I'll show in the next video in the series, Advanced Plotting, is how to make the grid lines a little bit dimmer so you can still have them and still make them not be too distracting. Other questions you might want to ask yourself is, do you really want these lines connecting the dots? For example, this line here that connects these two dots, this isn't really data. Only the points are the data. And so it's sort of misleading. It's as if this is real data. Maybe the point in between is actually up there. You have to ask yourself whether or not you're going to mislead somebody by doing that. I like to have the lines as a dashed line just as a guide to the eye so you can follow the line easily. But those are some of the questions that you might want to ask yourself. But the point is, don't do too much. Clearly, we've improved greatly from this original graph. And so now we're ready to see how to do all this stuff. Now we know roughly what it is we want to do. Okay, so let's go. Okay, so I'm going to start off with a very basic result. Plotting experimental results. So you do a lab and you get some data points and you just really quickly want to make a plot of your data. So I thought about how to do this in Python with the least number of commands. And I think I was able to do this with 3 lines. And here's those 3 lines. I think it's the shortest possible plotting script you can come up with. And here is what it generates. And so that is how easy it is to make a graph. And of course, when you make this graph in Python, it will actually pop up a graphical user interface where you can just press save, as I showed earlier, and you can put this in your report, put it on the internet, whatever you want to do with it. But this example also serves to show us some important things. Let me walk you through this in some detail so that we understand what it's doing. So this first line right here is importing the Matplotlib set of libraries. That is what generates all of this amazing plotting capability. Most of that capability is in something called pyplot, so you'll always want to put that there. There are other capabilities within Matplotlib, but for the purposes of this entire video series, we won't care about that. So just imagine that you are always going to type these as one unit. Now, what this as PLT does is it says, I don't want to type all of this every single time. I want to call it PLT. Now you can call it XYZ if you want, it doesn't matter, but traditionally it's called PLT. So if you go out on the internet and you look at other people's examples, probably they're going to call it PLT. But what's that for? What that is for is when I say PLT dot, that tells Python, use the routine I'm about to tell you about from here. Don't go anywhere else. Go here to look for how to do that. So this says, PLT says, go to matplotlib.pyplot, grab its plotting routine, and plot this data set. So you did your experiment. You have your data. You've put them in this list, 1.8, 0.66, whatever. You just type in your numbers right here, whatever it is that you're measuring, voltage, distance, velocity, whatever it is. And you make that list. And this says to set up a plot. So that's what that does. The third line right here, again, says go into Matplotlib pyplot and get the routine I'm about to use, which is show, and this says put it up on the screen. Go find the graphical user interface and put this plot up on the screen so the user can manipulate it, modify it, and save it. That's what this does. Brings up that graphical user interface. Now what I say here in these comments, each of these lines that start with this are comments. You should always put comments in your code. This last comment, what I say is Matplotlib uses deferred rendering. And deferred rendering means wait until the very end. That's what deferred means. And rendering means make the graph. So what you'll see in all of the scripts that I show you in this video is that you will do a bunch of setup for your plot. This is as simple as it gets. It's one line. And then when it's done, you tell it, go get that graphical user interface and render the graph. And that's called deferred rendering. Sometimes that's confusing because you think of plot as a verb and you think that this is going to plot it, and it doesn't actually plot it. Let me clear that up. It means make the plot. So already we have, I think, the shortest possible plotting script, and I think we've already learned a great deal about how Matplotlib and Python go about making a very simple graph like this. And if you save this in a file, next time you do a lab or anything else, you simply pull this file back up, type in your new data, and you will get a new graph. So all very, very simple. Okay, but now let's start to get into some details. Okay, we can do better. So I thought about an example of plotting data. So there's a city in New Mexico called Santa Fe, and I went to the internet to Weather Underground and found all of the temperatures for the month of December 2014 for the city of Santa Fe. You can see them here in the red and blue here. And I said, okay, let me plot those just so I can see graphically what the temperatures in Santa Fe look like in December 2014. So that was my data example. You could pick anything you want. Okay, so there's 4 steps to making a plot of that kind of data. And again, this data could be anything you're interested in. It could be from an experiment you did, a lab, a science project, whatever it is. 4 steps. Import the things you need to make your graph, store the data somehow, set the plot up, and then make or render the plot. 4 simple steps. So let's see how that works. Okay, so the first step is we import everything we need. And in this case, I'm using 2 different libraries. There's the usual Matplotlib as PLT. That will be in every single script, so just get used to that. By the end of this video, you'll be thinking about and typing that automatically. And then another one that I use here that I didn't need to use, but I did anyway, is called Numpy. And instead of typing Numpy, I want to type np. And so I will be using that in several places. I could have just used a normal list like I did before, but for certain reasons that I'll discuss later in this video, sometimes I like to use this to set up an array instead of a list. And I'll talk about that later. These NumPy arrays have certain advantages. Okay, so that's importing what I need to make the graph. Next, I have to store the data. So the way I did it for this example is I stored the data in these arrays. So I simply define the variable that I want to plot, Santa Fe high temperatures, Santa Fe low temperatures. I tell it that it's a NumPy array, just like that. And then notice there's a curved parentheses and a square bracket for this. And I just simply typed it in. And so these are all the high values for that month, and these are all the low values for that month of December 2014. That's it. Now, if I had had a lot more data, I might have actually wanted it in a file, or I might have wanted to read it in from a file. And that's possible too. In fact, in another video, I look at the temperatures in Santa Fe for the entire year. And in that case, I have a very complicated file to deal with. So I have a special video on how to read data from a file, which is pretty neat because with the internet, there's so much data out there that's so much fun to play with. That's a very fun thing to do. But here, I just typed it into the array. So that's how I stored the data. And then the next step, I set up the plots. Very simple. I just use PLT, as I said before, to call up plot from Matplotlib. And I simply plot Santa Fe high temp and Santa Fe low temp. And then it makes the plot. I have some things here that are a little bit extra that are kind of neat. This weird set of symbols, I'll show you at the end of the video another way of doing this, but after a while you get used to it and you want to use these shortcuts. I'll show you the long cuts at the end, but this says blue circles connected by lines, red triangles connected by lines. And so that's just a way of customizing the graph. And there's different ways of doing that. Once you get used to it, you like to do it this way, but I can imagine it's obscure if you're seeing it for the first time. And then I add some labels. That sets the plot up. Now I need to make the plot, and this will pull up the GUI, show me the plot, and I can go and print it. And here's what that plot looks like. So you can see there's the There's the blue circles there at the top. These are the highs. And down here, I have the lows. Okay. Now, one of the things to note when I make this plot, I never told it what axis to put it on. So what it did is it assumed that I would start at 0 and I would go up until the number of points were used up. And because that month has 31 days, that goes up to 30, because there's 0, 1, 2, 3, up to 30. And so it plotted it 0 to 30. And notice I didn't give it any other information over here, so it didn't know what to do. So in the next section, I'm going to show you how to fix that little thing. And of course, just to remind you, once you have your plot, press this to export it. Use this to customize the graph, whatever it is you want to do. Once you have this graphical user interface, you can do a lot of stuff. Okay, so let's just quickly move those axes over. That's an important thing to know how to do. So here's how that works. What I do is on this line right here, I create another array of x values. How does that work? I take the Santa Fe high temperature array, that's this array up here. I find the length of it, which I know is 31. And then I create an array from Numpy. And what this does is it takes the value in here, which is 31, and it creates an array that starts at 0, and it goes up to the number that are there, which is 0 to 30, which is what I don't want. That's what it's already doing. Then what I do is I add 1 to it, and now inside that array will be 1, 2, 3, dot, 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 up to 31, not this. And now day is an array that goes from 1 to 31. And now look, I include it here, and I include it here, so it plots Santa Fe high temperature versus day, and Santa Fe low temperature versus day. And then I force it, let me clear that, and then I force it to make the x limit 1 to 31. And I get a plot that goes from now 1 up to 31. And you can play with that and customize it however you want. But keep that in mind. Two things. One, you can set up the x array to make it be whatever you want, and you can force the graph to be between two specific limits. I just wanted to show you that. Okay, but let's get back to customizing our graph. As we talked about earlier in the video, it's really important to add labels. So let's see how to add labels. Okay, so everything in this part of the script is all the same as it was before. But now what we're going to do is we're going to say plot, which goes to the Matplotlib libraries, pulls up the legend command. And notice I just have these parentheses with nothing in them. That's because I want to use only the defaults for this case. So how does it know what to do? The reason legend knows what to do is because I actually had given it the information previously. Notice it never used this before. I had it there, but it wasn't using it. Now, it will use it and put up a legend. Then I add three more things. Plot an X label, plot a Y label, and plot a title. And those should be pretty self-explanatory as to what those are. And this parentheses right here actually should be over here. Doesn't actually make a difference, but it certainly looks better. And then make the plot. So here it is. There's the plot. It has a title. It has the Y label. It has the X label. And it has the legend. Okay. And if this is starting to seem overwhelming and complicated, keep in mind that after a while, you'll naturally put a comment at the top so you know what you're doing. You will always import the same things here, and almost all of this will be the same. It's just really this middle part that will be changing. So if you've saved this in a file, you pull it up next time and it reminds you how to do everything. So you don't have to remember how to do all of this stuff. And if there's something new and interesting that you want to do beyond this, of course, many people have tried to do this, and you can go on the internet and find lots of different variations on this plot. Okay, next let's add some grids to that, and let's add some shading. Okay, So look right here at the bottom here. I put a comment here, fancy stuff. And to put a grid is really simple. I just call the grid command. And again, I don't need to pass anything to it because I'm doing the default. So that's pretty simple. I just get a simple grid. What might I put in there? If I want to make the grid like a little bit dimmer so it's not so dark and distracting, I could put in there alpha equals, say, 0.5. Put that inside those parentheses and I get a grid that's a little bit dimmer. That's what those parentheses are for. You have to have them there, but if you're using the defaults, just keep them empty. Next, I use two commands also from Matplotlib, and those is called fill between. And notice what fill between does. It goes from day, that tells me the range on the x-axis I want to fill. I'll get to this later because I'll show an example where that's not so obvious what you picked there for the calculus example. And Santa Fe high temperature, day, Santa Fe low temperature. Now what I do for the high temperature is I give it a color, which M means magenta. And notice I use the alpha to make it a little bit dim. Then the next fill command goes from the bottom of the axis up to Santa Fe low temperature, and I make that white, which covers up the magenta part at the bottom of the graph. Now there's another way of doing it. I did this way just to show how you can do one color and then do another color that covers up part of the graph. Another way to do this would have been to use one fill between command and then just do day, Santa Fe low, Santa Fe high, and it would have put the shading between those two. So there's two ways of doing it. This is a little bit more flexible, but you can try it either way. Great homework problem. Go try it the other way and see what you get. Okay, so show me it and let's see what we get. So here you can see we now have a graph that's starting to look pretty good. We have the high temperatures, the low temperatures, and the magenta region shows us the total range of temperatures that were experienced during that month. And so we have a really nice graph here. It's got labels, it's got a grid, nice shading, easy to read, and easy to export just by pressing the save button. Okay, so I wanted to go into a little bit of some technical details here because this can be very useful, but it can also be fairly confusing. Whenever you make a graph, you need to decide what the X range is that you want the plot to be on. And there's several ways of doing this in Python, but it's also an example where when there's this much flexibility, it could also be confusing. So I don't want you to be confused. So there's three ways that you can decide what points you want on the x-axis. And this is going to be important in the rest of the video because so far we've been plotting data, which is just points. But what we're going to look at next is plotting functions, and we need to know where to evaluate those functions. So the three ways are, one, Python has a list, and that's what I started off with in the beginning of the video, which is just a sequence of numbers in square brackets. So this is what a list looks like in Python, and I showed you how to do that. And Matplotlib will happily plot the values in a list, or if you want those to be the X values, you can type those in. But typically what happens is you have so many points, you don't want to type these in yourself. So that is why I usually use Numpy to do that. You can actually do this in Python itself, but Numpy has some advantages. So I just want to go straight to that. So Numpy has this command called arange, and the way you look at it is it says numpy.arange, and you get 10. And that will automatically, as I mentioned before, generate 0, 1, 2, up to 9. So if I wanted to have a list of 10 elements that go from 0 to 9, I can just use this command and I get it. Now imagine maybe that's so simple that I'd rather use a list. But imagine if this were like, I want to plot 1,000 points. Then you're not really going to want to type that in. A third command that's also very useful is called linspace. And linspace does something very similar to arange, but it takes more arguments. And I'll show you in a second what happens if you don't give it enough arguments. And so in this example, what this says is make an array, start at 0, end at 10, and make it so that there's 100 different values in between. So this is really great when you're trying to plot something, because you usually know the beginning value, you usually know the ending value, and you can specify the number of points so that your curve comes out smooth. And so that's the one I think I probably use the most, although I use all of these. It's good to know all three of them. So which should you use? Learn all three of them. I think maybe linspace is the easiest for making 2D plots, but it's a matter of preference. So it's really up to you. But let me demonstrate how to do that and show you something really important about using Python, is that if you need to learn these kinds of things, it's really nice to just go into Python and just try things. So here I'm going in and I've imported Numpy, and I just said, what happens if I do np.arange 10? Notice I get 0 through 9. If I do linspace with one number, it gives me an error. But now, if I do 1, 10, 5, I get 5 numbers between 1 and 10. If I do 1, 10, 10, I go from 1 to 10 with 10 numbers. If I do 1 to 10, 15, it goes from 1 to 10 with 15 numbers. And so you can see I have a lot of control over how I can generate arrays with different numbers. And this is very useful when you're doing plotting. So the best thing to do is watch these examples. Notice in that case I was able to use a step. And so here is a summary of what you just saw down here. In general, the way arange works is you give it a start, a stop, and a step, 3 arguments. Notice up here I was just using 1 argument, so it uses the defaults. Linspace has a different syntax: start, stop, and then the number of points that I want. Okay, so use the list, use arange, use linspace, whichever ones you want. Just get used to it. Like I said, just go into the interpreter, practice so you get used to what it's doing, and it's best to become pretty familiar with it. Now, the reason I use Numpy is because sometimes you want to take the array that you make and do element by element operations on it. And that is really useful when you're doing anything mathematical or scientific. So even though Python itself has a range command without the A, I would say get used to using the Numpy libraries, because they allow you to do such amazing things when you start to do mathematical stuff. Okay, so I just wanted to pause and take this break to go into some of this little bit technical detail. Watch the video a few times if you need to, practice, but it will be worth understanding these 3 ways of making arrays. Okay, now let's use it. Okay, now suppose we want to plot functions. Okay, we're doing algebra, trigonometry, calculus, geometry, and we want to know how to plot functions, not data. Okay, so here is a great way to do that. Okay, so as usual, this part right here doesn't change. And as usual, most of what's down here also doesn't change. So we only need to focus on these few pieces. So what I do is I define an array, which is called x, obviously for the x-axis, and I'm using here linspace. And what I'm doing is I'm going to plot a graph that starts at 0, it goes to 10, and it has a total of 30 points. Okay. Now this is the reason you want to use NumPy arrays and not the lists, the standard list of the Python language. I'm going to take that array and I'm going to stick it into a function, and that will generate another array that has the sign of all the values in this array. So whatever length this array is, this array will be the same length, and each of the elements in this array will be the sign of all the elements in this array. And then I do the same thing for cosine and call that y2. Okay, very simple. Then I plot y1 versus x. So I plot this function versus this. Let me clear that up. And then I plot y2, which is this array, versus x versus this array. Okay, and then because I want to have a beautiful graph, I give them both descriptive labels. I put a grid. Of course, I want a legend. I label the x-axis. I label the y-axis, and I give it a nice title. And I end up with a graph that looks like this. And when I'm ready, I can either customize it by pushing on this, or I can save it and export it to wherever I want it to be. So that's the way to plot functions. And just in summary, the two things that make this very possible are being able to define the range of values where I want to evaluate the function, using NumPy, which allows me then to compute the function and generate a new array wherever the x value array is, and then I can easily plot one array versus the other and get a beautiful plot that looks like that. Okay, great. Okay. Just a quick thing, if you are using these for trigonometry, keep in mind that NumPy knows what pi is. So if you're doing trigonometry, you can pull in np.py and it knows automatically what that is, and you can use it to generate your graphs. So a nice thing for trig. Okay, so now let me show a calculus related example that also uses these functions, and it shows a slightly more sophisticated use of linspace. Kind of neat. So what I'm going to do is I'm going to define x to be an array that goes from -5 to 5, okay, with 100 points in that array. Okay, then I'm going to define another one, which I call xint for intermediate, and it only goes from -4 to 4. And notice I didn't give it the number of values, so it's going to default to 50. So it's as if I had put comma 50 there. That's what it always defaults to. Linspace makes a pretty good guess for you. So you can either put what you want or just let it default. Okay, so now I have two different arrays, one from -5 to 5 and one from -4 to 4. Okay, then what I'm going to do is evaluate two functions using those two arrays. So I define y using the x array, and then I'm going to evaluate y intermediate using this other array. So this will be evaluated at a different set of points than this one. Okay, that's it. Then what I do is I plot it. Now notice what I do is I plot y versus x. That's my main function here. It's called a Lorentzian. And I'm going to call it curve for my legend and give it a nice line width of 3 so I can make it a little bit easier to see. And then same thing, grid, legend, x label, y label, give it a nice title, and that would be just the blue line that you see over here. But this final one, I use fill between, remember we saw that earlier, and I tell it fill between the x-axis at these points, which are from -4 to 4, up to this curve right here, which is the same function evaluated at different points, and make it the color green, and the alpha makes it a little bit softer so you can kind of see through it. And that, of course, is what gives you this green shading that's in here. And notice that the function goes from -5 to 5, but the shading goes from -4 to 4. This is a great example if you're doing calculus, how you can get a picture of exactly what you're doing using that really beautiful command fill between, and using the fact that linspace allows us to generate values on the x-axis in a very nice customizable way. And that's why I had that very technical little interlude there, because it's very useful. Okay, let's keep going. Okay, this one's pretty neat. Data visualization. We live in the world of data, big data. There's data out there on the internet. Everybody's analyzing and thinking about data. So I thought about a really good example to illustrate scatter plots. So I went back to that Santa Fe data that I had, and I thought about this. In that data, I have the high temperatures and I have the low temperatures. And I asked myself, if I were looking at data, what's one of the questions I'd want to know the answer to? I might want to know if the data is correlated. So a simple question when it comes to weather or climate is the high that day correlated with the low that day? Or is sometimes I have a really low temperature in the night, but that day I get a really high temperature? Or is it always that the temperature at night is always higher when I know that the high temperature is always going to be higher. So how would I know if those are correlated? So here's what I did. Taking the tip that I gave in the beginning of the video, I went back and pulled up that script that I had before for plotting the Santa Fe temperature data, and I simply commented out all of the lines that I had before because I wasn't going to use them, but maybe I want to use them later. And I said, now I'm going to use the data in a different way, and it's very simple. What I did is I use a command out of Matplotlib called scatter. And what I did is I plotted the high temperature versus the low temperature. Notice it's not the high temperature or low temperature versus the day or versus time. It's high temperature versus low temperature. So if the high temperature is really high and the low temperature is really high, I should see a correlation. Okay. And then these are to customize the plot. Let me show you the plot first, and then I can tell you exactly what these do. But it's better if you see it. So here's the plot. It's really neat. So on the y-axis, I have the high temperature, and I have the low temperature on the x-axis. And so what you see is right away what this technique shows you is everything kind of falls on a line. And that says there's a definite correlation between these two pieces of data, and it just pops out at you. If the low temperature at night is really high, I can expect the day temperature to be also very high. And similarly, if it's really cold at night, it's typically really cold the next day. So that's a really nice way to look for correlations in the data. And it also shows you how to make a scatter plot. But doing this sort of data analysis is so much fun that I did a little bit more here because I encourage you to go find your own data and try to make these kinds of plots. So one of the other things I did is I changed the size of the circle, and I changed the color of the circle, and I changed the way they were filled. So watch what I did. I made the size of the circle bigger. I used the day. In this case, it goes from 1 to 31. If it goes from 1 to 31, I made the circle bigger. So small circles here corresponds to days earlier in the month, like December 1st, December 2nd, and so forth. By the time the day gets to be later, like towards the 31st, the size of the circle becomes larger. And I get these bigger circles that you see over here. So you can see, if you want to see how the days go from December 1st to December 31st, they go from the smallest circle to the biggest circle. So you can see the trend over time by changing the size of the circle. Same thing with the color, is I color coded the color by the day as well. So the earlier days in the month start off as blue, and the later days in the month end up with this sort of brownish tan reddish sort of color. So you can see the trend from the beginning of the month to the end of the month. And so, not too surprising, at the beginning of the month, as you were going into winter, you have all these blue points and it's warmer. And as we went from December towards January, we moved in this particular direction, and it got colder and colder, both in the day and in the night. And that's all very beautifully expressed by this choice of the size of the circle and the color of the circle. And then just to make it have this kind of a pastel color, I changed the alpha so it's not so harsh. Okay, so now let's return to that first graph that I made, because I promised you I would show you how to do that. Here's that graph that we kind of walked you through before. And now you can see it's very easy to do. It should be all very familiar to you. So there's the obvious in the beginning, bring in the plotting thing. In this case, I use Python lists. So these are normal lists because I wasn't going to do anything that needed me to operate on these. So I didn't use Numpy. So here's a counter example where I use lists. And then I plot everything. Pretty simple. But in this case, instead of using those little tricks, I actually write everything out. Color equals red. Marker equals a circle. Line style equals dashed. And line width equals 2. As I showed in earlier parts of this video, all these things can be shortened once you get used to it. But if you want to write it out so that you can see it, that's how you do it. Save the file and then use it later. And then, of course, you very familiar and expert now on putting titles, labels, legends, and grids. In this case, I forced the legend into the upper right. You could put it in the upper left, whatever you want, and you can then show it. If you want to save it immediately, the other thing I added to this particular script is a way to save the file directly in case you want to save it without using the GUI and pressing that save button. You can just save it directly and then you're done with it. So that's just yet another example and a slightly different way of making some of these graphs. So by now you should be quite expert. Okay, so what next? The video you just watched is actually one video in a bigger series of called Python in Education, which aims to bring Python in an educational environment for making graphs and doing other things in a very simple way. The one you just watched was this one. So if you want to see more, I have another graphing video which has advanced 2D graphs and covers a lot more details, lots of different types of graphs like log graphs, bar graphs. If this seemed like it was a little bit too complicated and there was too much Python and stuff that you didn't fully understand, you might want to follow this sequence and then come over and watch this video again. If you're really interested in data and plotting all types of interesting data like I showed in that last scatter plot, you should jump over here and go watch that one. This is all linked so that you can click on these boxes and jump to whichever video you want. And you don't need to type in any of the scripts in these videos because I put them all up on Google Drive, so you can just go grab them and start using them and start modifying them immediately. The link to the New Planet School Google Drive is right down there in the description. So with that, I hope to see you here again at New Planet School very soon.